Hey guys, so today we're actually going to be doing multiplying using scientific notation. Now I know you guys got to see this as a preview in the last lesson, but we're going to take a look to how we can actually solve it using scientific notation. So here we have a multiplication of scientific notations. We have 3 times 10 to the second times 2 times 10 to the fourth. Now there's different ways you could do this. So one of the ways, if you were going to do it just basic ways, would be to turn it into from scientific notation into standard form. So for example, 3 times 10 to the second would mean 3 times 100, right? Which is the same as 300. And 2 times 10 to the fourth would be 2 times, let's say 1, 2, 3, 4, 2 times 10,000, which would be 2 with 1, 2, 3, 4, which would be 20,000. And we can multiply them and we would get 6. And we have 1, 2, 3, 4, 5, 6 zeros. And we would get 6 million. So we could do it that way, or we could actually use a way to use scientific notation. Now, multiplying with scientific notation is actually pretty easy. So if you notice, we could take our two numbers, which in this case is a 3 and a 2, and we can multiply them. So 3 times 2 would be 6. I'm going to use the highlighter here. And then we could actually use this scientific notation. Now we know scientific notation always has a base of 10. So when we're multiplying with scientific notation, we can actually add our exponents. So we could say, well, 2 plus 4 would be 6. And we would get 6 times 10 to the 6th, which is actually the exact same thing as 6 million. And we could leave it in scientific notation. And we could multiply, oops, there you go, using that method, which is actually pretty easy. Okay, so we're going to take a look and try some of those. Okay, so let's take a look. So that was one example. Let's take a look at another example. So let me zoom in for you. Give me 1 second. Now the first problem we actually already did, so let's look at this second problem here. Oops, sorry, we just went full screen. That's okay. Okay, so we'll go second problem, which if you notice, we'll move that over, sorry, is 2.5 times 10 to the third times 3 times 10 to the fifth. So like I said, we could take those first two numbers and we could multiply them. So we could do 2.5 times 3, which in this case is 7.5. And we keep it times 10 because it's multiplication and it's scientific notation. And we could just add those exponents. So 3 plus 5 is 8. And we could keep our answer just like that. So we could have 7.5 times 10 to the 8th. Okay, pretty simple. Now let's just take it one step further. We're going to do 2 more examples and then we will give you one to try. So let's try this one. So we have 8 times 4, which is 32, times 10, and we could do 6 plus 2 is 8. Now, that seems pretty easy, but does anyone notice the difference between the problem up here and the problem down here? You're right. So this one actually isn't proper scientific notation because we only want one number in front of the decimal up here. So right now, our decimal is behind the 2. So we want to put this in proper scientific notation form, which is actually pretty easy to do. So in order to do that, we can move the decimal one place to the left, right? And we would get 3.2. Now times 10. Now because we moved that decimal, we want to make sure that we're going to change our exponent. So here's what I always remember. I remember this word called LARS, okay? LARS. LARS stands for left add, right subtract. So if I'm going to move my decimal to the left, I'm going to add to the exponent. If I move my decimal to the right, I'm going to subtract my exponent. So however many times you move the decimal, that's how many times you either add or subtract. So in this case, I moved it 1 time to the left. So I'm going to add 1 to my exponent. So I got 3.2 times 10 to the 9th. Okay, let's try one more right below it. We'll use that one as an example. So here we have 6.2 times 10 to the third and 7 times 10 to the fourth. So if you notice here, I can just multiply 6.2 times 7, and I would get 43.4, and that's times 10 to the 7th. But that's not proper scientific notation because there's two numbers in front of the decimal. So let's see what we can do. We can move it one time to the left. So because we're moving it to the left, right up here, we add. So we have 4.34 times 10. Now because I moved it once, I'm going to add 1. So we got 4.34 times 10 to the 8th. Okay, so let's give you guys some to try. Let me back this up a little bit. Okay, let's see if you can try the worksheet that you guys have in front of you. Okay, so here we go. So here you'll notice we have 4, let me zoom in. 4 times 10 to the 6th times 2 times 10 to the 2nd. So why don't you try that out? Okay, so you should have gotten 8 times 10 to the 8th. Okay, proper scientific notation, you don't have to change it. Okay, let's try the next one. 4.3 times 10 to the 7th and 7 times 10 to the 2nd. Okay, now if you notice, you actually should have gotten 30.1 times 10 to the 9th, but we need to change it into proper scientific notations. We got 3.01 times 10 to the 10th. Okay, let's try the next one. I'm gonna move that up a little bit. Actually, let me zoom out a little bit. Sorry, I'm zooming in too much today. Okay, let's try another one here. I'm sorry, this is all messed up. Bear with me. There we go. Now we're back on track. Okay, let's try the next one. Okay, 9 times 10 to the 3rd and 6 times 10 to the 7th. And you should have gotten 54 times 10 to the 10th. And when you put it into proper scientific notation, you should have gotten 5.4 times 10 to the 11th. Okay, next one. Okay, you should have gotten 17.2 times 10 to the 9th. But when you put it into proper scientific notation, it's 1.72 times 10 to the 10th. Okay, so pretty simple for multiplying. Okay, now let's try some dividing. Okay, so let's try this one up top. Okay, now dividing is very similar to multiplication with one slight difference. So here we have 8 times 10 to the 4th divided by 2 times 10 to the 2nd. So just like in multiplication, we're going to divide the first two. So 8 divided by 2 would be 4. We want to keep it in scientific notation, so times 10. Now, if we add when we're multiplying our exponents, what do you think we're going to do when we're dividing? That's right, we're going to subtract. So 4 minus 2 would be 4 times 10 to the 2nd, and it's that simple. Okay, let's try another one here. We have 36 times 10 to the 6th, and then we have divided by 5 times 10 to the 3rd. So if we do 36 divided by 5, I should get 7.2. Then we have times 10 to the 3rd power, because 6 minus 3 would be 3. Now, is that proper scientific notation? We have one number in front of the decimal, so yes, we don't have to change anything. Okay, let's try another example. So we have 84 times 10 to the 8th divided by 4 times 10 to the 2nd. So we could do 84 divided by 4, which in this case is 21, times 10 to the 6th. Now that's not proper scientific notation because our decimal is actually right behind the 1, and we only want one number in front of the decimal. So we can move it one time to the left, and we should get 2.1 times 10, just like it. Remember, Lars, left, add, right, subtract. Okay, 2.1 times 10 to the 7th. Okay, let's try another example. So we have 49.5 times 10 to the 8th, and then we have divided by 3 times 10 to the 3rd. So we could divide 49.5 divided by 3, and we would get 16.5 times 10 to the 5th. Now, is that proper scientific notation? No, it is not, because we want one number. So we want to move it once to the left. So we have 1.65 now times 10 to the 6th. And that should be our answer. Okay, so it's pretty simple. Now I'm gonna have you guys try some division problems on your own. So let me move this paper for a second. Okay, let's try this first one on your worksheet. Okay, so we have 12 times 10 to the 8th divided by 2 times 10 to the 4th. So what would you get? Okay, so you should have gotten 6 times 10 to the 4th, because 12 divided by 2 is 6. And like we said, we could subtract those exponents. So 8 minus 4 would be to the 4th power. And that is proper scientific notation. Okay, let's try the next problem. So we have 42 times 10 to the 7th divided by 5 times 10 to the 3rd. And you should have gotten 8.4 times 10 to the 4th. And that is proper scientific notation. So you don't have to change anything. Okay, let's try the next problem. So we have 96 times 10 to the 6th divided by 4 times 10 to the 3rd. Okay, you should have gotten, well, originally you should have gotten 24 times 10 to the 3rd, but we want to put it in proper scientific notation. So once again, our decimal is here. We want to move it to the left once, which becomes 2.4 times 10 to the 4th. Okay, last problem. 54.9, move it over a little bit, sorry. 54.9 times 10 to the 7th divided by 3 times 10 to the 5th. Okay, you should have gotten originally 18.3 times 10 to the 2nd, and in the end, with proper scientific notation, you should have gotten 1.83 times, oops, that moved, times 10 to the 3rd. Okay, so I hope that makes sense, and we're going to be practicing this a little bit more in the future. Good job.